Welcome to the GOTO podcast. In this episode, Aaron Parecki, author of OAuth 2.0 Simplified, and Eric Johnson, senior developer advocate at AWS, guide you through some of the main reasons to use the OAuth 2.0 authorization framework, along with what it takes to build a secure web server. Created for developers by developers, GOTO gathers the best minds in the software community. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in Chicago, Amsterdam, and Copenhagen, and by subscribing to the GOTO Conferences YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Tell us, and this is kind of a broad stroke question, but I want you to tell us the history of OAuth and specifically, why it was created. What did people sit down and go, oh no, we need something and it's OAuth? Lay that out for us.
Yeah, definitely a bit of a broad question. Could fill up a lot of time with this, but generally the reason that OAuth was created, it was started because there was this particular problem of using third-party apps to access APIs. So imagine like early Twitter days where you'd have third-party developers writing applications to view and post to Twitter. And the only way that that could work is the application would have to ask you to enter your password in that application. And that essentially means you're giving your Twitter password to some random developer, which is not great, right? And there was also this very common problem where applications would want to get access to data that's in your like Google account, like your Google contacts, and they would have to ask for your Gmail password. And that, of course, gives them access to all of your Google account, not just contacts. Right. So these things combined essentially meant that what we actually are looking for is a solution to let applications access some small part of your account while you are knowingly granting them that data, not actually granting them access to your entire account.
This idea of OAuth was created, and there was a first version, right? And in your book, you talk about when that came out, and now we're up to a second version. So can you give us a little basis on, or here's what was in the first version, and here's what brought us to a second. Can you kind of walk that history for us?
Yeah, for sure. So OAuth 1 and its minor revisions, 1.0a and things like that, it was all based around, it was the original framework for OAuth of this sort of delegated access pattern where instead of giving the application your password, you are logging in at the OAuth server and then giving it a token, some sort of thing that represents access. The way that OAuth 1 worked was that it required a secret, a client secret, for the application. So that application had to have a secret of its own when it was deployed, and then it used that throughout the entire flow. So it used it to start the flow, to ask for authorization, and also when it was actually using the tokens that it was given. Now, that actually has some really cool security properties. It's great when that is possible. And we would like to be able to get back to that world in OAuth 2. The problem is that in OAuth 1, because it requires the secret, you just can't do it on a mobile phone or a single page app.
Okay, yeah, that's what I was going to talk about. Yeah, go ahead.
So that's where it kind of breaks down, where because OAuth 1 was created sort of at the beginning of the mobile explosion where now mobile computing is just computing, but it was sort of the outlier then. It wasn't seen as a problem yet, but it turns out that you can't ship client secrets in a mobile app and have them remain secret because anybody can just extract them. So that kind of just breaks down the entire model of OAuth 1.
Right. It's so in my world, I build a lot of spas. I work with Serverless and we build spas and the service is the back end. And that was always interesting to me because when I first started getting to OAuth, and that's one of the reasons that made me really excited to do this interview is because, I was confused. OAuth, I'm so confused, which I think a lot of people are. And we'll talk about this a little bit later, but your book really kind of, number one, it kind of laid it out and said, hey, it's not the black box mystery you think it is. And so I really want to say thank you for that, because as I read it, there was a couple of things like, okay, that makes sense. Now I understand that. So
I'm glad to hear it. Yeah.
But as I was working with this, and I didn't realize, and I'm not a mobile developer. I've done some, but you really got to be desperate if you want me as your mobile developer. But I didn't realize that you could so easily get a hold of that secret. I know you could on a SPA because there it is. It's exposed right there in the JavaScript or wherever you're storing it. But that was a really interesting point in that. Okay, that had to be changed. So how was that changed in OAuth in 2.0?
Right. So it was clear that there was that problem. The other problem was that because of the way that secret was used in OAuth 1, it required going through a signature mechanism of canonicalizing the request and signing all the parameters. And that process was just complicated and people would often get it wrong. So effectively, there was like one library in every language that someone figured out, and then everybody just used that forever. So it was like not easily replicatable code, which is not really great. Like that's not a good spec, right? A spec should be a blueprint for writing code that is easy to translate into code. And
agree.
So that was that was the other problem. So these two things combined basically meant that, okay, let's do another revision. At that point, it had been brought into the IETF, into the OAuth working groups. The working group started working on a new spec, an OAuth 2. And the idea was, okay, we're going to start with we're going to change the assumptions we're starting with, and we're going to make it work from the beginning in these environments like mobile apps and single page apps. And the way that worked at the beginning was effectively just not using a secret for those applications. So it actually became possible. So there were two parts to that. There's when you are creating an application that's a mobile app or a single page app, you're just not going to get a client secret anymore because there's no point in pretending it's secret. Second, access tokens are not going to require anything besides the access token to use them. And this is sort of like we all understand this now, like this concept of, oh, you have this string. This is what you put in your authorization header and make a request. That's pretty normal. But that idea of switching from something that required signatures to we're just going to use the string as an access token, that was a pretty big leap between OAuth 1 and OAuth 2. Yeah. That actually was the particular thing that the editor of the spec, Aaron Hammer, had some very strong opinions about. And he ended up quitting because of that, essentially. And a lot of other things. It's a very stressful job being an editor of a spec. But that was one of the things that he was really set on. Of like, no, we need signatures. We have to, like, just using a string as an access token is not enough. And from a theoretical security standpoint, that's absolutely correct. Like, it is riskier to have just a bearer token. That's what they're called. So what it means is that if you have the string, the token, that's all you need in order to make API requests. So if you hand it over to somebody else, they can make API requests that look the same as the real app making API requests, which means attacks are harder to detect. If someone steals an access token, there's no real way to tell that it's been stolen. So that's sort of the problem with bearer tokens. In practice, I would say it hasn't actually been a problem in most things.
About a year and a half now, I've been kind of diving in my role at AWS, working with Cognito and some of our other ones. And how does OAuth work? And in my head, when I first started, OIDC, JWT, OAuth, those are all the same thing. Well, I've quickly learned they're not, right? JWT is not OAuth. It's, well, I'll let you explain it better than I can. But let's go basic for a sec.
Yeah.
So we hear these terms thrown around. We have AuthZ and AuthN. Right. And then and when you're someone like me and you're talking in public and you're not sure which one you mean, then it's just auth.
Yeah.
Because you're like, I'm not sure what I mean. So can you talk through, compare those auth in, authz? What are they? What are they?
Okay. First of all, I absolutely hate those terms because they're too similar, and especially for non-native English speakers. And I think it's a sort of cute thing that like the spec world has been like, oh, we're going to use these two terms because they sound the same and it's fun. But no, it's like confusing and it does not do anything to help the situation. So
agreed.
I like to think of it. So OAuth generally falls in the AuthZ, and then OpenID Connect falls under AuthN, right? That's where you'll see the breakdown. I like to think of it instead of using those terms as one is you're trying to get access to APIs. The other, you're trying to figure out who the user is. Those are two totally different problems. Right. Completely different.
Agreed.
Problems.
So let's expand the words then. AuthZ is authorization. AuthN is authentication. Did I get that right?
Yep.
I know you don't like the words, but that's what we hear. So talk about you kind of compared it, but talk about those differences.
So the idea with authorization is that you're trying to authorize a user or an application to act on behalf of a user. That's the OAuth use of authorization, right?
Okay.
We're trying to say this user is authorizing this application to do these particular things on their account. Right. This application is trying to access your friend list. This application is trying to post to your Twitter account. This application is trying to get access to your Google Drive files. That's all about, authorizing that application.
Okay.
But in what's actually going on the wire is that application is going to get some access token and use the access token to access APIs. And when it does that, it actually doesn't need to know who the user is. The user's identity has nothing to do with whether or not that application is allowed to access those APIs. So you can imagine, like, if you have an application that's going to let you upload files to your Google Drive, it just needs to be able to make that API request that says, upload this file. It doesn't need to know who you are, right? So authentication, on the other hand, or where the OpenID Connect part comes into it, is entirely explicitly about communicating who the user is to the application. So it's essentially a mechanism for figuring out, for communicating user information like email address or name or user ID to the application.
Okay. So if I were to say that in simple kind of Eric Johnson terms, I would say authentication is all about who you are, and authorization is all about what you have access to.
Yeah.
Okay, alrighty. Okay, yeah. And I think when I first started, that was confusing to me. It's like, those are the same thing, authorization, authentication, but they're not. And that's an important distinction. And it's important to understand that OAuth, and correct me if I'm wrong, because I'm going to say the statement as if I'm an expert, but I'm not. You are. OAuth is all about what you have access to, right? It is about the authorization. It is about saying, as an application, you have access to this based on, not based on who you are, but the authorization you've been given.
Yep. It's about giving applications access to data, right? It's not about deciding who can access what data within a system. It's not a permissions model. It's not how you do your own access policies. It's about getting a specific application access to some limited portion of a user's data. Okay.
That makes absolute sense. I think where I also was confused, and I think a lot of probably listeners would be confused as well, is, a lot of times, and they get pretty gray on some of the implementations that I've seen, is we do use this authorization as almost not an authentication, but I guess it is kind of almost an access point. And I guess that's where OIDC comes in, right? I think originally it was, hey, this is just authorization, but it certainly has kind of come in and become, hey, here's your, we're using this as an authentication somewhat.
I think you can think of that as if you want to go down that road, you can think of it as you are authorizing the application to allow it to know who you are. You're authorizing it to access your profile information.
All right, so I don't want to, I've got it's got my dog ears, and it's been through, I've carried it around with me quite a while. Love the book, by the way. And again, it was really helpful to me to OAuth was the black box mystery to me. So this opened a lot of things up. So I want to kind of climb into the book. If we can, with the rest of our time here. So first question I would ask you is, when you sat down to write this, who was the target audience for your book?
Yeah.
Eric Johnson?
So I actually went through a couple of iterations, honestly, because I had started the book quite a long time before it was actually published. But the target audience now is essentially people who are trying to actually work with OAuth systems more than just at the level of, I'm trying to just, throw a library into this and move on. So if you're writing a library or writing a OAuth server or at all involved in the decisions behind doing things certain ways, if you're one of the decision makers of we're trying to evaluate whether or not we should do X, Y, and Z, that's really who it's for.
Okay. Alrighty. So let me ask you a question based on that, because I was reading this, and one of the things, there's a huge section of the book that talks about building your own OAuth server, right? Would you recommend that to anybody? I mean, obviously you would. It's in the book. I didn't mean to say it that way, but that's not something to take on lightly.
It's definitely
for security
not.
reasons. Would that be? Would you come to a company and say, build your own, or use one of the many services that are available? What's your approach on that?
I would definitely not recommend building your own, and that's not just because I work at Okta, where we provide an OAuth server as a service.
Sure, yeah.
But it is not a small undertaking, for sure. And there's a lot of things that can go wrong, a lot of ways to get it wrong. And a lot of those, thankfully, are documented in, one, my book, also the specs, also many extensions to the specs. And it is a large undertaking. So that said, there's sometimes reasons to build it into like if you're building a small scale API that's really just going to be like a self-contained thing, it actually ends up being more complicated to integrate it sometimes with an OAuth server, but it also very much depends on the situation of like, if you're supporting third-party developers or if you are just trying to do this for your own APIs, there's few reasons to actually go and build this stuff from scratch as build an OAuth server from scratch.
Right.
But one of the things that I did want to do in that book is point out exactly what it takes to build one so that you know what you're getting yourself into if you think you're going to go down that road. Because I think too often people look at the spec because it's written from sort of describing the client to OAuth server interactions and leaves a lot of the details of the OAuth server itself out of the spec because it's not necessary for the communication between the two. So people look at that and say, oh, I can do that, not a big deal, without really realizing actually what they're getting into. So I wanted to lay out all the steps of like, here's what you need to know in order to build an OAuth server successfully so that hopefully you realize like what world of hurt you're about to be in.
Well, and I took that, it was as I was reading it, and I'm not going to lie to you, there's a little niggling in the back of my head said, I might build a serverless version of this at some point. Now, they may already be out there, but, it's like, oh, yeah, I could do that. But I think what was interesting as I was reading, because, you get very detailed in this section. It's like, hey, in this, verification, you should be asking these questions or showing this to your users and stuff like that. And there's a couple of times like, I've had some that didn't do that, and I would have liked to known that, And so that I think that's where the really, of course, if I'm going to build my own, but I think that's where the book really became helpful. Also, is looking at some of the implementations that I have seen and used that are in the wild. Are they really covering all the bases? We've talked about flow. We've talked about different things like that. Just for users who may not understand OAuth. Let's talk about some of the flows that are available, that are probably most secure. And in your book, it was interesting when I was looking at the OAuth, some of the OAuth documentation, it becomes a surprise to you. Your name comes up everywhere. Like, oh, okay, just click on this. They come back to your website a lot. So you're obviously, an authoritative person in this, and I appreciate that. So let's talk about some of the grant types. One, what does a grant type mean, and how does that work?
So, OAuth is modeled around this idea of grant types. And the idea with the grant is that's the mechanism by which an application will get the access token. So the goal of an application in OAuth is to get an access token. That's how it's going to then go access an API. So it needs some way to do that. And the way that it will do that is called an OAuth grant. And there are several OAuth grants described in the original spec. There's a few have been added later. Some have been removed. And we try to recommend only the most secure current best practices of those grants. So the most common one that you're probably familiar with that you've used almost certainly because everything uses it is the authorization code grant. And that is the redirect based flow where you are, on this page, you click a button, you get taken over to the OAuth server, log in there, and then you get brought back. And that
with a token, right?
With a temporary code in the URL, which the application can then go and exchange for a token.
Okay. So then what happens?
So that flow is it's start of the application, go over to the OAuth server, you log in, come back to the application with a temporary code. The app exchanges that temporary code for an access token, and then you're logged in, and the app can go access that API. After the grant is complete, it does not matter which grant was used, effectively. Like, The grant is just the very brief exchange of actually getting that token.
Okay, so here's your token. Go do your thing. All right, and there's and we may or may not get. There's a couple tokens you can get back: an access token, an ID token, but there's a refresh token. So that's in a sense another grant type, right?
It is, and it's listed in the original OAuth spec as another grant type. It's the refresh token grant, and the quick summary of a refresh token is that it's a way that an app can get new access tokens without doing the redirect-based grant again, without bothering the user. So the user has to be involved in that first grant, right? The user has to go to the OAuth server and log in.
Authenticate for it, yeah.
Mm-hmm. The refresh token is so that the app can get a token without the user being present. So you might also hear it called offline access, where the app needs to do some work without the user being at the computer anymore. So it needs to get offline access to their account, and it'll then get a refresh token so that access tokens don't have to last forever.
Okay. Alrighty. So what was interesting to me, and in the book we talk about some strategies, and before I even ask that, I'm going to make this statement. You can tell me if I'm right or wrong.
Okay.
Probably the most secure way of doing this is the authorization code grant, right?
With Pixie.
With okay. Oh, is that a Pixie? Okay, I always say okay, that makes sense. With Pixie, which we'll talk about. When I saw Pixie or PKCE, Pixie in your book, I did not know what it was. Now you explain it fully, but I had never heard of that, and so that was really helpful. So authorization code with Pixie is the most secure way. You have a couple of strategies. You talk about short token or short access code expiration, long refresh code, or you kind of explain that. And I'll real quick. So you'll get a token, and like you said, just before it expires, your app can refresh and get you back in, or even after it expires, you can get a refresh token to do that. What's the advantage of doing a short access token period but a long refresh?
So one of the good things, but also challenging things about the spec is that it leaves a lot of these decisions open. So when you're building or setting up an OAuth server, you get to decide how long your tokens last. And you have an access token and a refresh token. And you get to decide the lifetimes of those. And it's entirely up to you. There's very little guidance in the spec because it is actually very dependent on what you're building and the security considerations around it. So you might choose a short access token lifetime, but long refresh token lifetime, because you don't want the risk of stolen access token. You want the risk of stolen access tokens to be diminished, to be lower. So if an access token is stolen, it only lasts for 10 minutes or something, right? Or if you're using an access token format where your APIs can validate the token without looking up anything externally, this is probably the most common is if JSON Web Token access token, then your APIs might be looking only at that string and not actually checking a database of valid users or applications, which means that token is effectively a cache of the state of the system when it was issued. And if your access tokens then last a really long time, you effectively have a really long cache window where the cache is essentially out of date, maybe out of date.
Okay.
So you might be then acting on old information if you are using an access token that was issued a long time ago that is self-contained. So shorter token lifetimes means you reduce the window where that validation may be wrong. And then refresh tokens, you bump the refresh token lifetime out to however long you want your users to not have to log in again. With shorter refresh tokens, it means that when the refresh token expires, the only thing the app can do is start a flow again and get the user to log in again.
Okay. So I'm going to think this out loud for a second. So if I'm a user, I get a short token. If someone were to have gotten that token, I hope not, but if they do, they only have the window of that token to access my data.
Yep.
So that's going to lock that down. Now, while my refresh is longer, if someone gets a hold of that, the minute the system detects a refresh token being used twice, then it kicks it out.
Yep, that's one way to do it. The other way is that if the application does have a client secret, then the refresh token actually isn't useful by itself anyway.
Okay.
Right. But if without a client secret, you're right. Then the best thing you can do is detect replays of refresh tokens.
So let's talk about client secrets for a minute. So with the OAuth 2 spec, they're kind of removed, right? We're removing client secrets because we can't do them in spas, we can't do them in mobiles. So there are some security that we can wrap around that. And one, and I said I'd come back to it, is Parecki. So explain Parecki.
Yeah. So with the authorization code flow, I kind of stepped through a high level of it. And the authorization code flow with the client secret is mostly secure, although it turns out Parecki actually solves a very small attack, even if you have a client secret still. So what Parecki does is Parecki basically creates a new secret for every request, for every initiation of the flow. So when the app goes to start the flow, the app has to first create a new secret for that particular exchange. And it uses that secret to calculate a hash of it that's sent out publicly, but then it has to use that secret when it goes and exchanges the authorization code. So effectively what it does is it means that the authorization code that gets returned in that response, without a client secret, that could be used to get an access token. An attacker could steal that to get an access token. Yeah. With Parecki, it's no longer possible to steal it because the secret has actually never left the device during that whole exchange until it's actually used to get the access token.
Okay. All right. That makes sense. So with Parecki, that's really, it's on the client. I mean, it's kind of the onus is on the client to invoke, because what I'm seeing and did some reading on this is, go ahead.
No, go ahead. I'll clarify.
All righty. It's okay to tell me I'm wrong. I'm never wrong. I had a t-shirt that says that, but sometimes I am. But so from what I'm understanding, if I build an OAuth server, I may support Parecki, and it depends on the server, but I've seen a lot of them support them optionally. Mm-hmm. So if the Parecki's passed in, then implement it and use it the second time. So that's what I'm driving at is if that's the case, then it's the onus is on the client to say, hey, I'm going to implement that Parecki protocol, if that's the right word, to use that. Does that make sense?
Yeah, it makes sense. So I guess just a couple things to clarify there. An OAuth server that supports public clients like mobile apps and single page apps should always support Parecki. There's no reason for them not to. So if they are letting public clients not use Parecki, that's definitely bad. Now,
so it should enforce, not just support Parecki, but enforce it.
It should enforce it. Now, for confidential clients, there are a lot that don't require Parecki or even don't support it. Now,
so I'm going to interrupt you one sec. For what kind of, I think you broke up or I heard you, for what kind of client did you say that?
Sorry. So for confidential clients, I've definitely seen OAuth servers that don't require Parecki or don't even support it. Now, this is more recent guidance coming out of the OAuth group, but it turns out Parecki is actually important there as well. And the attack that prevents is too intricate to get into here. But we do have some videos on the Okta Developer YouTube channel if you're curious about diving into the nitty-gritty on that. But effectively what it means is that Parecki is a good idea, even if you do have a client secret, because it binds that one request to end to end. So it protects a flow even for confidential clients, which effectively means all clients should just do it all the time. But your point about whether the client's enforcing it or not, the reason that Parecki is a great idea for all OAuth servers to support is that the way that the mechanism actually works is that the authorization server gets the opportunity to deny requests that don't use Parecki. Whereas other solutions to these similar problems rely on the client developer to get it right. And the OAuth server can't even tell if the client developer is doing it right. Okay,
that makes sense to me. So bottom line, use Parecki, PKCE. You harp on this in your book really well, the requirement of redirect URL verification.
Yeah.
So why are listing or verifying the redirect URL so important? If I'm building an OAuth server.
Yeah, if you're building an OAuth server, verifying.
Yeah.
So actually, a recent requirement in the latest OAuth security best current practice is that redirect URL matching, exact redirect URL matching is now required. The original OAuth spec didn't require it, just sort of recommended it, but it is now required.
That's crazy talk.
There's two main reasons for it. For public clients, the redirect URL is effectively the only confirmation of that application's identity. And because there's no client secret, there's no password for the app. The only way that the OAuth server and the user can know that this is the real app is by looking at the redirect URL. So that's one. Without that, then it would be possible for someone to initiate a OAuth flow as a public client using a different redirect URL and then get that user's authorization code, or in some cases access token if you're using the implicit flow. And that's just, clearly bad. The other problem is actually nothing to do with OAuth. It's the fact that any form of open redirector can be used in many different attacks in ways that are very not obvious. So an open redirector is when one URL can be used to send somebody to an arbitrary URL. So you can use these to chain together attacks where someone can visit a link that is otherwise very nearly legitimate and then end up on an attacker's website with sometimes very dramatic effects. So if you just search for open redirector, you'll find examples of attacks that have happened that way. And a not validating redirect URLs is a form of an open redirector.
All right. So, and I started building this out. So one for security, but another interesting thing that you call out, and there may be people listening going, yeah, Eric, we all knew that, but I didn't. Okay. So I'm going to talk about it. We'll see. It was interesting to me. It's like, well, yeah, but I don't want to list every URL that could possibly come from it in my domain. And that was, I'm not proud of this, but that was one of the first thoughts that came to me. It's like, or I will always force them back to the same one and then try to figure out some way to redirect them. But that's already built in, right? There's already a mechanism built into this, and that is, and I'll let you say it.
I don't know where you're going with this.
Sorry, I was going to state. Great, I'm leading you well.
Great.
Yes, so that is state. So I didn't know about the state, property. So can you explain what the state property does?
Yeah. So again, this is something that's actually changing the recommendations from the OAuth group, the recent recommendations, because of Pixie. So Pixie solves cross-site refresh. Pixie solves CSRF attacks, and if you've implemented Pixie properly, then that attack is solved. It used to be the case that state was the solution for CSRF. And without Pixie, state is absolutely required to prevent CSRF. However, Pixie does it better. So once you're using Pixie for that actually frees up the state parameter to do what you're talking about, of sending the user back to different parts of your app. So you can implement this where there's a single redirect URL in your application. And it's sort of like, this is the route that's going to be catching the response from the OAuth server and finishing the OAuth exchange. And then you want to know where to actually send the user to. Do you want to send them back to the home page or their profile page or their notifications page or the shopping cart, the checkout page, right? So you need to figure out how to send them there. And now you can use state for that. So you can just basically put in a string in your state that's like shopping cart.
Here's the reader. Yeah.
And now I do want to mention that don't build an open redirector yourself, right? Don't allow yourself to redirect to arbitrary locations by using the state variable.
Okay.
You need to still have an explicit list of allowed redirects that your application is going to redirect to. Otherwise, you're building an open redirect. I hadn't thought of that.
So I hadn't thought of that. So don't build a hole into your own security system.
Yeah.
Okay.
So if you do use full URLs, then you just need to make sure you have your own explicit list of URLs that are allowed.
Yeah, that's a good call out. I had not thought of that. So when it comes back and it asks me to redirect, I'm going to verify that it's one of the allowable redirects in an array of redirects that I allow. So okay, very cool.
But it does let you use the state parameter to send the user back somewhere without having to have the state parameter have randomness in it because you're using Pixie, which solves CSRF.
Okay, gotcha. Could you use, and now I'm just thinking out loud, I'm off script here. Could you use Pixie to, and maybe I'm make sure I understand, because no, you couldn't. Because, if you encrypt a string, because in Pixie you're creating a string, could that string contain the redirect?
Interesting.
So, mark that down. Someone write that down, Eric.
I'm going to have to think about that. So, there's some implications there that I have to think through.
I'm sorry, say again?
There's some interesting implications there I have to think through.
Yeah. And you've got state, it's there, but I was just curious, would that be something, because that's related to that request, specific to that request. So could that,
it would have to include enough randomness still. So
Right. So yeah, okay. So
actually, probably wouldn't work because the Pixie challenge or verifier has to be a certain length. It has a very specific length limit.
Okay. All right. That makes sense. So let's jump here on when we're talking about security, talking about how it kind of lock things down. There's some security. If I do decide to build this serverless OAuth server, which it may happen, and I'm gonna push it out there, and I'm not looking to replace anything, but I want to say, yeah, I understand that I can build that. But there's some security considerations I need to look at, and I want to ask about a couple. Maybe have you kind of explain it and how we fight that. And the first is phishing.
Yeah, OAuth phishing is definitely a real thing, and it's becoming more and more prevalent as people are solving traditional phishing. Traditional phishing is becoming harder because we've done a good job of upping the security of these things, and now attackers are moving to OAuth phishing. So the idea with OAuth phishing is that it's not actually an attack on the spec or finding a flaw in the server. It's actually like any phishing attack, tricking people into doing something. So it's tricking people into authorizing a real application to get access to their data, where that application is created by an attacker. And it's not even like trying to mimic a real application or anything like that. It's just like there's some application registered and someone accidentally authorized it to access their account. There was a very large example of this a couple of years ago with Google. And it's had ripple effects through a lot of the ecosystem of applications that use Google data, like use Google APIs. And this was, it was called OAuth phishing or an OAuth worm or whatever you want to call it. But it was effectively that same problem where someone went to the Google developer site and made an app and gave it the name Google Docs, just typed that in when they registered the app, got real credentials for that app.
Oh, wow. Okay.
And then started a real OAuth flow. Like if you send somebody a link to log in, that starts an OAuth flow. And if they finish the OAuth flow, that real app gets real access tokens that can access their data.
Sure.
So there's no like hack, right? It's just tricking someone into clicking this link. So they would spread this by sending an email saying, this person shared a file with you, view it in Google Docs, open in Google Docs. Clicking that link would start the OAuth flow to this fake app, attacker's app, which would say Google Docs is trying to access your Google Drive or whatever. And then all of a sudden the attacker's app can now access all of your data. And one of the scopes it also asked for, one of the permissions it asked for was the ability to send email from your Gmail account. So then it would then go into your Gmail account and send an email from you to everybody in your address book with that same message. So it just spread super quick.
That is maliciously brilliant.
Yeah. Thankfully, Thankfully, that was the extent of the worm. It didn't actually like do anything really, but it was an effective demonstration. Okay.
So so if I'd have gotten that, number one, I'm going to be, so let's say this a couple times. Anything that asks to send email for me, that's a red flag.
Yep.
Right. Would you agree? Yeah. So that's a red flag right there. So the first thing, I guess, if we were to fight this, the first thing I'd do is look closely at what it's asking to do. How many times do we just go authorize? It's like signing contracts without ever reading, right? And so we really need to get that in our head that this is your information. Read everything.
This is why that consent screen is so important. So that dialogue that says this application is trying to do this, this, and this. The design of that page is very important because if you pack too much into it, people are going to just skim it, glaze over, and click the big green go button, right? And if it doesn't say enough, then you may not actually know what the full implications of that are. So there's this balance you have to strike. And that's why designing that page is so hard. And why this is one of the reasons why making an OAuth server is so hard, because you have to get that right. Otherwise, you're going to find yourself being in the middle of a phishing attack.
When you were listing, here's the things you saw, and I said, well, this is very detailed. And it really, when you said that, I was like, okay, that really clicks. Because that, I don't want to be responsible for having something open up like that. So very interesting. Okay. Yeah. So, all right, here's another one. Talk to me about clickjacking.
Yeah, clickjacking is it's actually mentioned in one of the earliest security specs in the OAuth group. The idea with clickjacking is basically if you have like a web page and then if you have another web page embedded in an iframe and someone is trying to type in their password or click a button that says okay, If you put something else over that where they can't actually see the iframe, you can do it in a way where the clicks like bubble through. So it's the idea of like stealing a click where the user thinks they're clicking on something, but they're actually clicking on something else. So in OAuth, the idea is that you would iframe in a OAuth page that's trying to grant access to this user's account. And then over it, you would put like download free wallpapers for your phone, right? Click the download. You put the download button over the OK button. And then when they click it, it actually goes through and clicks the OK button. And then they don't even know that that's happened. But thankfully, I feel like this is not super relevant anymore because most OAuth servers at this point don't allow themselves to be iframed in, which is the real problem there.
Okay.
And they'll pop themselves out of the iframe. And there's many other reasons why iframing in an OAuth page is a terrible idea. Actually, any login page, it's
iframes in general are a bad idea.
Yeah, there's
my opinion, but
there's like
there may be a
specific uses of them, but no, generally they just cause a lot of trouble.
Yeah. So as a user, is there any caution you would give me on? I mean, is there any way? And I agree with you; it's probably pretty edge case now. But is there any way I can tell?
Clickjacking,
other than expecting the code?
I don't think so. Yeah, because
that's a tough one.
That's a tough one. But I also feel like it's not even that important anymore because most of the OAuth servers have solved that themselves. The phishing is the one that users need to be aware of because that is something that the only line of defense is the end user there.
And once again, I would say treat the accept button as writing your signature and read everything before you do it.
One of the things Google has done to address that worm, that phishing attack, is change a lot about their OAuth flow. So they've done things like if an application wants to be able to send email, they actually have to go through a very expensive vetting process, approval process. And there's a handful of other scopes of these types of access where the application has to go through manual review as well. The email one is the sort of like extreme, but there's like Google Drive and things like that where there's like potentially sensitive data there. They have to go through a pretty extensive review process as well. And there's even now just registering an OAuth app at all, if you want it to be used by anybody besides yourself, you have to at least go through a minimal approval process now. Whereas it used to be you just sort of
vetting going on.
Yeah, it used to be you just show up, register an app, get keys, and you're off and running. Anybody can use it.
Breathing, give me access. Yeah. So okay. We talked about redirect earlier. The last kind of security, or probably not last, but the last one I've got on here is redirect URL manipulations. And we talked about redirect URLs, but what do we watch for in that?
I guess the last trick with redirect URLs is in the mobile apps. So with web-based redirect URLs, we have the advantage of DNS and HTTPS certificates to do most of the validation for us. So if the OAuth server is about to redirect the user out somewhere, there's a pretty good guarantee that it's going to work because generally browser security prevents those attacks of like the coffee shop Wi-Fi taking over gmail.com and serving a bad page because we've got HSTS and all the certificates and all that stuff now. On mobile, it's a very different story. So there is this concept of app claimed URLs where there's some form of verification the developer of the app has to do to prove they own a URL that can be claimed. But there's also the custom URL scheme model. And custom URL schemes have no registry. So instead of http:// you do like example or to-do : as your redirect URL scheme for your mobile app, but there's no registry. So any app can claim any of them, which means any app can pretend to be any other app in that sense. So for those, the redirect URL does not act as any form of identity verification. Whereas in the HTTPS world, it acts as a minimal form of identity verification.
What are some key takeaways that you want users to have or readers to have? What if not? You can say if nothing else, I want them to understand this. What would you say?
Yeah, I would say focus on learning the authorization code flow with Pixie because that's just the default most secure way for the most different kinds of environments. Also, OAuth is not as complicated as you think it is. There are some complicated parts, but it's not as bad as you think. And it's worth learning a little bit in order to actually understand what's going on. and don't build an OAuth server.
Don't build your own. There's plenty out there, and they're doing it well,
there.
right? So yeah, no, I agree. But I'm still gonna in serverless, maybe we'll see. I'm not gonna publish or anything, but I just want to see if I can do it. But no, yeah, I agree with that.
It's a fun
I will
exercise.
tell you, and I know I've said it already, but the book really opened up some of the questions I had. I was surprised that there's some flexibility in the spec, and that it could kind of be user dependent sometimes, or server, whoever built the server. So yeah, but it is a lot simpler than I thought, or it's not near as complex as I thought. I think sometimes we just don't explain it well, and your book fixes that. So I really appreciate it. I really appreciate your time. I want to know where I can order that shirt. Obviously bigger than that one, so you'll have to.
Oh yeah.
Yeah, that's a cool shirt.
I don't have these up anywhere yet. Actually, this is. I know, right? I got these because
It's a missed opportunity right there.
Well, if I do post them online, they will be at OAuth.wtf.
Okay, that sounds great.
Yeah.
All right, well, with that, I appreciate your time, Aaron. It was a great conversation. Thanks for teaching me.
Absolutely. Thanks for the time.
Thanks for listening to this episode of the GoTo podcast. Head over to gotopia.tech for lots more content from the brightest minds in software development.